Hi, everyone. Well, I'm Kate Keating, and that's me. I thought that you might want to put a face with the voice. Some of you I met at Open House, which was awesome. But for those of you that I didn't meet, I wanted you to at least be able to see me. This is, I got to say, a little bit awkward for me because I'm standing in an empty classroom, not really teaching anyone, and it feels weird because I don't have students here to ask questions and probe some of these things with me. But at any rate, hopefully this will feel somewhat like a lesson for you instead of somebody just throwing some information out to you and then you have to be left up to yourself to kind of figure things out. So today we're going to start slowly in section 2.5, which is implicit differentiation. By the way, this is all on my website. If you go to it, Ms. Curry has all the information for the website. I will also have this up on my YouTube page, as well as a PDF of the lesson once I'm finished with it. I will save it as a PDF so that you can access it from home or anywhere that you need to. You could print it out if you want to. Okay, so implicit differentiation. Well, first let's start with explicit differentiation, which is what you've been doing up till now. Oh, and also pause whenever you need to. Just let Ms. Curry know that you need to wait to pause it, take some notes. Don't get behind so that you can pay attention. Okay, at any rate, explicit form is when we have y written as a function of x, such as y equals 1 over x, which also is equal to x to the negative 1 power. If I were to multiply both sides by this x, I'd end up with the implicit form. The definition simply says it's not explicit. If we take the derivative of the explicit form, then we get negative x to the negative 2, which is also equal to negative 1 over x squared. And that's just using our power rule. Well, what happens when it's inconvenient or impossible to solve for y? Such as y cubed plus y squared minus 5y minus x squared equals negative 4. Well, we're going to start with something that's a little bit more easy than that one. Although that would be an easy one. I'm going to start with fewer terms. So let's start with number 1. It's 2x squared plus y squared equals 4. Well, taking the derivative of 2x squared is easy. We bring down the 2, we use our power rule, and we get 4x, reduce the power by 1, and we get to the first power. Okay, now, the tough part is, what do we do with the y? Well, normally, let's take a little sidebar over here. Normally, you have y equals, say, 2x minus 1, and you would take the derivative of y with respect to x, and you get 2. So this y actually turned into dy dx. We're going to do something that's a little bit like that, and hopefully you'll see the correlation. We want to take the derivative with respect to x of y squared. And then over here on the other side, the equal sign, if we take the derivative of a constant, of course it's 0. And what we're going to do next is we're going to use the chain rule. We want to take the derivative of y squared with respect to y, but we have to multiply it by dy dx so that the chain rule will work. Let's take a look at that. What does the chain rule say? The chain rule says that if we have dy over du and du over dx, that is equal to, so long as these two are the same, it is equal to dy over dx. Now, if you take a look, the same thing is going on here. So this dy and dy up here are the same. So I'm going to take the derivative of y squared with respect to x, but it's going to look a little bit different than the way you're used to seeing it. So let's go ahead and write down 4x plus, let's take the derivative of y. Let me switch colors here for you so you can see. We're going to take the derivative of y squared with respect to y, and that's 2y. And then this requires no action. We just write down next to it dy over dx. There's nothing we can do with that. And that equals 0. Okay, now what we want to do is solve for dy dx, because the whole point of this is finding out what the derivative is. So we subtract the 4x, and we get 2y dy dx equals negative 4x divided by 2y. Negative 4x over 2y, which we can then say is equal to negative, when we reduce the 4 and the 2, 2x over y. And that's the derivative of 2x squared plus y squared equals 4. Now you may be saying, why don't we just solve for y? What's the big deal? This seems like a lot of work. Well, it's not going to be a lot of work soon. I'm going to show you how you're going to do it. You're not going to put all of that work on your paper, because that would be silly. But if you were to solve this for y, you would actually have to take the square root of both sides, and you'd, of course, subtract that 2x squared plus 4. So if you were taking the square root, of course, you're going to get a plus and a minus. Now you have a whole bunch of stuff to take the derivative of. You've got to take the derivative of positive square root of negative 2x squared plus 4, which is a chain rule because that's to the 1/2 power. And you'd also have to take the derivative of negative square root of negative 2x squared plus 4. Again, the chain rule. And this will not be what your answer is. However, it would be equivalent to it, and that is a much simpler, the way we've written it, and with implicit differentiation, much simpler answer there. Okay, so let's go up and look at number 2. X squared plus 5y cubed equals 1. Okay, x squared is easy. So we go ahead and take the derivative of x squared, and we get 2x. Plus. Now here's the shortcut, so you don't have to write all of that work out. If you take the 3, what we do is, let's go back over here. In red here, you're going to take the derivative of whatever it is in terms of y. So you take the derivative as if it said x there, and then you're going to slap a dy dx next to it. Okay, so bring down that 3 and you get 15y reduced by 1, you get 2 dy dx equals 0. Okay, let's solve for dy dx. Subtract the 2x. And divide by 15y squared. Negative 2x over 15y squared. And that's it. All right, here's one for you. Try number 3 on your own. 2x to the 4th minus 3y squared equals 9. So if Ms. Curry could pause the video at this point and give you all time to try this on your own, and then I'll show you what the answer is in just a moment. Okay, so we want to take this 2x to the 4th, bring our 4 down, reduce by 1, minus 3, whoops, excuse me, not 3, minus take the derivative of 3y squared, you get 6y to the first, and then you put that dy dx next to it. And again, it's equal to 0 because it's a constant. So let's subtract the 8x cubed. And divide by the negative 6y. All right, so let's reduce that. We're going to make it positive. It's going to be 4x cubed over 3y. Okay, so we're starting out real slow here. Let's take a look at number 4, because we are going to have to use a product rule for this one. 2x to the fourth minus 3xy squared equals 9x. All right, first one's easy again. Bring that 4 down. We get 8x cubed. Okay, now we have a product rule with the x and the y squared. So I'm going to leave this negative 3 out front. I'm going to open parentheses, and now I'm going to do a product rule. That's the first derivative of the second. The derivative of y squared is 2y, and then dy dx, plus the second, which we leave as y squared, times the derivative of the first, which is just 1. And that equals the derivative of 9x is 9. Okay, now, there are a couple of things you can look at. You might be used to taking the, or using the product rule a different way. You may have actually used negative 3x as your first term. You'll come out with the same answer either way. Different teachers teach it different ways, and I'm not sure exactly how Mr. Lloyd taught you. So you can either leave the 3 out front and then just use these 2 with the product rule, or you can use the negative 3x as your first term and the y squared as your second term. And in that case, you would have a plus right here, and then deal with the negative as you were taking the, the product rule. Okay, so what I'm going to do in this case is I'm going to distribute, this negative 3. So I get 8x cubed minus, we've got 3 times 2, which is 6. We have an x, a y, and a dy dx. And then a negative 3 times y squared. That equals 9. All right, now I want to solve for the dy dx. So first I'm going to subtract 8x cubed and add the 3y squared over. So I'm going to have negative 6xy dy dx equals 9 minus 8x cubed and plus 3y squared. And divide everything by negative 6xy. So our derivative is going to be 9 minus 8x cubed plus 3y squared all over negative 6xy. Okay, so at this point, maybe this is an odd problem. You can check your answer in the back of the book. And perhaps it has a positive 6xy on the bottom. So in that case, what they've done is taken the negative in front of the 6, brought it up top, and distributed it through the numerator. I don't care which you use. They're all correct to me. If you're doing the correct math, coming up with the correct answer, you are good to go for me. Think of it this way. Think of the solutions, or the answers, I should say, that are in the back of your book as the multiple choice options that you'll have on the AP exam. Can you turn your answer into the answer that's in the back of the book? Because you will have to be faced, or you will be faced with that once you get to the AP exam. Anyway, I'm hoping this was a success today. If you have questions, concerns, comments, please let Ms. Curry know. I can't wait to meet you guys.